Hey everybody, idly ho to you. It's Mr. Kaczynski. Going to go through the first part of the Chapter 3 test, basically modeling linear relationships here. Here we go. So we got Leslie and her sister is giving her a collection of glass animal figurines. Glass Animals, by the way, my favorite alternative band right now. At that time, the value of the collection was $120. Then Leslie bought several new glass animals for $475 each. So we got this value of $120 when she got it, and we've got the increase of $475 for each added figurine. That's going to come into play here. So we're going to start off by writing a recursive rule that keeps track of the new figurines and the value added to the collection. So here we go. Let's set it up like this. We're going to start off with our starting amounts. 0 months or days or, zero additional figurines, just the ones that she initially got. The value was 120. We hit enter. Then we're going to take the number of figurines and keep continually increasing that by 1. And we'll take the value and keep continually increasing that by 475 each time we add a new figurine. And then we can hit enter on the calculator as many times as we want. So let's do that on the calculator right now. So we'll hit the squiggly equal sign. It's called set or parentheses, called set notation. 120. Enter. And then we'll do it again, and we're going to say answer number 1 increase by 1, and comma, answer number 2 increase by 475. And when we hit enter, we'll see we now have one more figurine, and our value of our collection went up 475. At 2 additional figurines, our value of our collection went up $9.50. All right, write an equation in the form y equals ax plus b to describe this relationship where y is the total value and x is the number of new figurines. All right, let's go. Y equals 120 plus 4.75 times x. Okay, where x is the number of new figurines and y is the total value of the collection. Okay, so I could check that by doing 120 plus 4.75 times 2, and I should get 129.5. There it is. All right, explain the real-world meaning of the values of a and b in your equation. Well, just like I was saying when we were writing the recursive rule, 120 is our starting amount, and the plus 475, that's our added value. So here's what we'll write. How about we say A is the starting value of the collection, as in when her sister, Leslie's sister, gave it to her. So there's the real life context. All right. And B, what about B? B is the value added to the collection each time a new figurine is acquired. Should we use that's a big word, huh? So that's our rate of change, we would call that. Use the equation you wrote in 1B to find values of Leslie's collection if she buys 15 new figurines. I think I need a little bit more room here. So we'll do y equals 120 plus 4.75 times 15. All right, 4.75 times 15 is 71.25, as in the value of the collection went up $71.25, and when we add 120 to that, we get the total value of the collection, which is $191.25. And then 5 is a little bit backwards because it says if Leslie's collection is now worth this much, how many figurines has she acquired? All right, well, 224.50, that's the value. That's going to be our output Y. Okay, it started at 120 and it's gained $4.75 for each one of those unknown number of figurines. Well, let's take 224.5 and we'll subtract 120 from both sides of this equation. That gives us 104.5 equals 4.75x. And then if we divide both sides by 4.75, we'll get the number of figurines, which is 22. So 22 additional figurines have been added. Moving on. All right, we got suppose an automobile cost this much when it was new, and each value it decreases by $935. Again, I kind of see this value that's starting and then this change right here. So we could probably fill out the rest of this table to get A here. We'll do 15,400. That's our starting amount. And then we got to subtract $935 in value. That gives us 14,465 after 1 year. 13,530 after 2 years. And there's our answer, $12,595 after 3 years. And why not? We'll hit it one more time. $11,660 after 4 years. Write an equation to relate the value of the car Y to the number of years elapsed. Okay, so Y equals value, its start was 15,400. Not going to use any commas in my equation. Minus $935 per year. So there's my equation. Use your calculator to graph the equation. Use window settings that allow us to see where the graph crosses both axes. Okay, indicate the window you used. So I'm going to go to my calculator here. Let's get those plots turned off. Let's go type our equation in here. 15,400 minus 935x. So if I use a standard window, that is negative 10 for the x minimum, 10 for the x maximum, negative 10 for the y minimum, and 10 for the y maximum, we're not going to see anything. We're not going to see any line here. So let's try, that's option A. Let's try option B. So 0 to 15,400 and 0 to 10. I don't think we're going to see much here. Okay? Nope. Don't see much. Let's try this third one here. Window. Let's go 0 to 20 and 0 to 16,000. I think this is going to work best for us because this is like 0 to 20 years and this is 0 to $16,000, and we know the start of the car was a little bit under 16,000. There it is. There's our graph. So option C. The one we want. What is the coefficient of x in your equation? Well, the coefficient of x was that negative 935. Okay, so negative 935. Coefficient of x is like the number that's being multiplied by x. The value of the car decreases by $935 each year. That's what that means in real world terms. What is the y-intercept of the graph? Well, that's that 15,400. So 15,400. This is the value of the car when it was purchased. It's our starting amount. Where does the graph cross the x-axis? It's right about there. What does this point mean? So I could use my trace function, and I could go down to where it hits the x-axis. Okay, I want that y value to be 0. And that is, oh boy, somewhere like 81 point, somewhere like 16 point something, maybe 16.4, 16.5, 16.6, something like that. Well, there's a way we can actually solve this, and that is that we could put 0 into our equation. We could say 0 equals 15,400 minus 935x, and we could solve that equation pretty easily, actually. Just take 0 and subtract 15,400 from it, and then divide by negative 935. There's our x value, our x-intercept. Yeah, about 16.5. And what does this represent? In 16.5 years, the car will be worth nothing. That's where its output, y, is 0. So that's where its value would be nothing. Next up, we got the sequence here. Starts at negative 14.3. We're going to write a recursive rule to keep track of the term number and the term sequence. So there's something a little bit different about this. When we're talking about term numbers, we don't start at 0. This is the first term, negative 14.3. So I'm going to start at 1. The first term is negative 14.3. Hit enter. And then every term thereafter, what's going on here? We'll figure that out in a second. So we're going to go answer 1. We're going to increase to the next term. And answer 2, what's going on? Well, we can figure this out. We'll take negative 13.5 and we'll subtract negative 14.3. That was an increase of 0.8, just like if we do negative 12.7 minus negative 13.5. It's another increase of 0.8. So we are increasing by 0.8 each time we go to the next term. Let's try that out, see if it works. So let's go 1, comma, negative 14.3. That's our starting places. And then we're going to take answer 1 and increase it by 1. That's our term numbers. And answer 2 and increase it by 0.8 or just 0.8. Second term, negative 13.5. Third term, negative 12.7. Fourth term, negative 11.9. All right, and this is going to be very useful to us because we need to, for part B, find the term number of the first positive term for the sequence. So if I just keep hitting enter until I get a positive term, negative 7.1, okay, gotta go a little further, negative 4.7, negative 2.3, there it is right there, there it is. The 19th term would be 0.1, so that's why our answer is the term 19, or yeah, I guess it's just 19, or the 19th term. Getting down to the home stretch here. All we got to do is write equations for these tables for y in terms of x. Okay. Well, we're giving the y-intercept. That's like our starting amount. And then we can pretty clearly see here that every time x goes up 1, y goes up 1.5. So it's going to make it pretty easy to write our equation. We'll go y equals 4 plus 1.5 times x I'm even going to check it on my calculator. Let's go to y equals, let's punch in the equation, 4 plus 1.5 times x. If I go second graph, I can see all these values, 4, 5.5, 7, 8.5, 10. That should be 13, shouldn't it? Or no, oh, 11.5. There you go. I got the right one. All right, next up. I don't see the y-intercept. Let's worry about slope first then, okay? As x goes up 1, y goes up, let's find out, negative 0.8 minus negative 3.5. And we get our, oops, I didn't punch it in. Let's try it again. Negative 0.8 minus negative 3.5. That was a change of 2.7, an increase of 2.7. So now we can write our equation. No, we can't, because we still need to find the y-intercept. Well, let's take the negative 3.5 and we'll subtract 2.7. That gives us negative 6.2. All right, so that fits the pattern. Now we can write our equation. Y equals, how about negative 6.2 for our starting amount, plus 2.7 times x. All right, and again, we can check our answer. Let's go negative 6.2 plus 2.7 times x, second table. And you're going to see all those values, the 1 and the negative 3.5, the 2 and the negative 0.8, the 3 and the 1.9, so on and so forth. One more here. Let's figure out slope first. So here we got an increase of 1. And here I see a decrease of 7.25. We can also see that the y-intercept is 7.75. I think the thing that makes this one just a little bit different than the others is that it's got a negative slope. So we got to make sure to include that. So we're going to write 7.75 minus 7.25 times x. And I think we'd be silly to not check our answer. Let's do so. 7.75 minus 7.25 times x, second table. There's negative 3, 29.5, negative 1 and 15, 0 and 7.5, 2 and negative 6.75, and so on and so forth. All right, that'll do it. If you got good notes and you got your homework done, you'll be eligible for a retake. Let me know if there's anything that confused you about the video, and I'll try to take another shot at explaining it to you. Have a good one. Adios.